Okay, so today we are going to be learning about osmosis. Osmosis happens when you put cells inside of water. Like cells are in solution. So the most important cells that you have that are in solution are your red blood cells, which are inside a solution called plasma. So in order to understand what happens to the cells when they're placed inside a solution, we have to learn some terms and some concepts. The first one is tonicity. Tonicity Tonicity is a measure of how many solutes are dissolved in a solution, how much stuff is dissolved in a solution. Solutes, some examples of solutes are salt, sugar, any other stuff that you dissolve inside a solution. What else is in a solution is water. If you want to make Kool-Aid, you take Kool-Aid powder, which would be your solute, and you take water, and you put them together and you get a solution, which we know as the Kool-Aid drink. There are three types of solutions: isotonic, hypertonic, and hypotonic. Okay, we're going to learn what each type of these mean. So the first one is isotonic. So isotonic. You look at this. What do you notice about the salt and the salt? What do you notice? What do you notice about the amount of salt inside the cell? And what do you notice about the amount of salt outside the cell? Well, iso means the same. So you should notice that they're the same. Okay? You can remember an isosceles triangle has two of the same sides. You can remember this iso prefix. So, if there's the same, is there a high concentration or low concentration? No. So the molecules are at equilibrium, so they're not going to move anywhere. So what the definition of isotonic is, it means there's the same amount of solute, which remember in this case is the salt. The salt is equal to your solute inside the cell is outside the cell. We're in a solution. This is the solution. In a solution, inside the cell. And remember, iso means same. So if you put a cell inside an isotonic solution, you have your cell and you put it in a solution with isotonic that are the same percent. What happens, okay, is that there's no concentration gradient, which is also known as equilibrium. So the cell stays the same size. It won't change in size. And that's easy to remember because here we have that word same again. Okay? Now, let's go to the next slide. Hypertonic. So, if we see hyper means more. Okay? Hyper means more. And remember, with tonicity, we're looking at the solutes. So what it means is it means that you have more solute in a solution as inside cells. So if you have more solute in the solution, that means you have less water in the solution. So think about a really, really sweet Kool-Aid that's going to have a lot of Kool-Aid powder. Okay? That means you have less water. So that means you're going to find more That means you're going to find less water in solution. Remember, if you have more solute, you're automatically get less water. The outcome, okay, this is now we're going to look at the water. We have less water in the solution. If you have a really sweet Kool-Aid, what are you going to do to make it less sweet? You're going to add water. So you're going to get that water from inside your cell. Your cell has a lot of water. So the water moves from inside the cell to outside. And what do you think that does? You have a water balloon and you will release water. What's going to happen to the size of your water balloon? It's going to shrink. So we can write the cell shrinks. Here you can see we have water leaving your cell. This is osmosis. We have water moving from high water to low water. So you'll notice here it's the opposite of salt. It's moving from low salt to high salt. But it's moving from high water. There's more blue molecules here, less blue molecules here. High water to low water. Let's go to our next one. Hypotonic. So, hypo means less. Hypo means less, or hypo means low. You need to remember that because it rhymes. Hypo is equal to low. If you're hypothermic, that means that you're freezing to death. So the definition is that you have less solute in solution than outside. Oops, no. Than inside the cell. So that means you have more water in the solution. So an example of a hypotonic solution, okay, so example of hypotonic solution is just pure water. Okay, so I want you to think back about our case study and what happened when the guy put pure distilled water in the guy's gut. So what happened? So the outcome would be, if you have all this water outside and all this salt and less salt inside, that means that this is where your sweet Kool-Aid is. Your sweet Kool-Aid is inside the cell. So you're going to have to add water to it to make it less sweet. Got an arrow with a black line, you're going to have to add water. It's less sweet on the outside, it's more sweet on the inside. So add water. So where are you going to get that water from? Your water will move from high to low and move into the cell. So if you add lots of water into the water balloon, what's going to eventually happen? It gets bigger and grows, and eventually, what's going to happen to that water balloon if you keep on adding water inside? You're keeping on adding water inside to the cell. It's going to eventually burst. Just like your water balloon will eventually pop and fill it up too much, it'll eventually burst. So make sure you're doing your cue column. But let's look at this right here. I'm not going to tell you, you're going to do that on your own. What's happening to this one? You can see it's kind of like rupturing. It's bursting. So go back. This one is staying the same. And this one is shrinking. So I want you to go back and I want you to find out what each one of these are. Okay, you can see here the cell wall is staying the same. The cell membrane is getting smaller. Here it's perfectly nice. And here it's getting like kind of like pushing on the edge now to get out. So let's just step backwards. outcomes in your notes before this. Remember, do a cue column, put questions down, and a 3 to 5 sentence summary.